So this is what we would call data pre-processing. What we get to work on now is the model building and being the data scientist. And then a future for this solution that I see would be something post-processing, like turning it into a dashboard, or integrating it with Twitter or something interesting like that. That would be quite exciting. So for our evaluation, we're using the root mean squared error. So the way you can think of root mean squared error is a standard deviation. So it sounds fancy, but in your mind, just think about it as root mean squared. I'm going to talk a bit about the IDs here. So each of the squares that we cut Zimbabwe into, we labeled them with a number. So 0, 1, 2, 3, all the way up until 488, I believe. We then have the year, month, and day. If you notice the title says that this is a prediction competition. So we will be doing prediction in our starter notebook and solution, but that does not mean that you can't do forecasting. We do have the dates, so if you're advanced and you're really excited about that, please do explore forecasting. So going back to the ID, we've got the year, the month, and the date, and we've pulled information for each month. The prizes, there are 2,000 Zindi points. I had a lovely discussion with one of our users on what are Zindi points. So if you download and submit the sample submission, you will receive 25 points. If you submit the starter notebook, the minimum number of points you can receive is 50. And there's a little hyperlink there, so if you go to it while reading further in, you can see that there's this whole curve of points you can receive. What these points mean is they get added to your profile, and then you get bumped up the competition leaderboard, but also our overall leaderboard and our overall search functionality. So the more you compete, even if you end up at the bottom of the leaderboard, it still means some points to your name. This competition is going to run until the mid-August, so please do stick around until then, and please ask any questions on the discussion board. In this call, we're going to do a how to enroll in your first competition. If you are confused or scared or you've forgotten or you can't find this video, please get to the how to get started with Zindi. And there is a short video that shows you where to click, where to find the data, where to ask for help. I know some of you are looking for teammates, so the next video shows you how to create a team. I'm also going to discuss a bit about creating a team on this call at the moment. We then have how to update your profile. So Rose explained the importance of why it is great to have an updated profile, because your profile on Zindi gets to go through to our recruitment Zindi talent search where recruiters are looking out for you. So just follow this video on how to update your profile. The last two videos here are how to use Colab. Colab is a Python notebook interface, just as how we've got Google Documents and Google Sheets and Google Slides, we've got Google Colab. And this allows you to run Python notebooks. If you have Anaconda or Spider on your computer, you can use that. If you have another coding platform that you want to use, you can use that. Just Colab is my preference. Finally, we have the rules. The rules for this competition are pretty standard. The most important rules are highlighted by bullet points at the top. If you want to double check anything, please come back to the rules, especially around data sharing. This competition, you're allowed to use and distribute the data by a CC by SA 4.0 license, but some data is proprietary of the client, and we are privileged to get to share their data with you. So just keep that in mind. If we scroll to the top of the page, we're going to see the data tab. On the data tab, we can see that Zimbabwe was split into 533 equal areas. We also have the different types of variables that were included. So if you want to read up more about any of the variables, you can do so there. Next, we have the leaderboard. So if we go and look at the leaderboard, we can see that some users have already started making submissions. Root mean squared error means that we prioritize the smallest score. So that's why we can see Mfomelani and Eco at the top. I want to point out over here that we've got a public score, but we also have a private score, which can be a bit confusing. This is to add a bit of spice to the competition. So just before the competition closes, or when the competition closes, the private leaderboard is revealed, and that constitutes the final ranking. I'm going to pause and see if anyone has any questions. I'm seeing that everyone's busy saying hello on the group. This is great. Has anyone had a chance to run the starter notebook yet? You can just put up a hands down, hands up or hands down. Ooh. This is really frustrating that I can't share my screen. Rose, can you maybe show the financial inclusion competition and we can talk about the starter notebook and making a team over there?
You can share the notebook. I can open it on my end or...
Okay, brilliant. I've just sent it to you on Slack, so you can open it up there and then we can go through it.
Okay, just a minute. I think there's a question. We can tackle that as we open.
Thanks. Lydia, I want clarification on the competition. During the period the competition is running, must I make a submission every day or can I work on a project and just do one submission? That's a great question. You can make one submission the whole competition, or you can make 10 submissions every day. It just depends on your workload and how interested you are in competitions. Some competitions, such as the environmental ones, like the fire predictions, I get really excited about those, so I tend to put in more effort. But then there are some fields that I'm not particularly strong in, so I don't compete, although I know I probably should. But yeah, you can choose when and how to compete. Enoch, you currently are receiving a message saying that it's only open to certain participants. Enoch, I'm going to send you a message after this and see if we can clarify that afterwards. Usually what that means is that you haven't been put on like the secret whitelist, but I'm sure I can rectify that with you afterwards. Some competitions are for only like set people. You were specifically invited to this, so this is why the competition's only open to you. You'll also notice that some competitions have got a secret code. A secret code is normally for a community or a hackathon, such as the Deep Learning in Daba, which I hope many of you are going to. After a competition, can I share my notebook on GitHub? Yes, please do. So there's a couple of majority, yes. Some of the competitions, such as if we're working for a bank or if a competition is for a client that wants to implement the solutions and put them into production, we normally state that in the rules saying the top winning solutions can't share their code. However, most competitions on Zindi, we want to encourage you to share your solutions on GitHub, on the discussion boards. It's a great place for others to learn, but it also adds to your technical CV. And we encourage you to put your GitHub on your CV. How did you obtain the past fire records? Oh, Perkins. This is a great question. How did we obtain them? If you go into Google Earth Engine, it takes a very big amount of trickery and hard work to figure out how to pull information and aggregate it. But that is something that you can do, and maybe we can have a discussion on the discussion board about how that's done. Ah, Rose, you have done amazing work. Well done.
Great. Just let me know if I need to upload the data.
No, so I think we can run this without. So if you haven't created a Colab notebook or done a Colab notebook before, just follow that video. But here we're going to go through the notebook together. What's quite nice about Colab is that it allows you to do some terminal commands. So if that's a bit scary to you, don't worry. But the first cell we have is to list the CSV files we have in our repository. When we list them, we see that we've got a sample submission, a test, a train, and a variable definitions. These are all the files that you'll find on the data page. So if you just download them and upload them to Colab, they will be there for you. Next, we import our main libraries. Our libraries are pandas. Pandas is great for data frames, merging, opening, viewing them. We then rely heavily on the sklearn libraries and packages. I strongly believe that you can get away with sklearn for pretty much all things machine learning. As soon as you start moving into the deep learning realm, which we are not touching at all today, then you might need to change your libraries and packages. But sklearn is a great place to start. And finally, we have matplotlib, which is to visualize your files or visualize plots. We read in our training data, our variable data. So we have short descriptions on the variables. If you'd like to see the variables in more detail, you need to go to the data page and you'll see the definitions there. In the variables folder or file there, I want to highlight the burned area. It is the percentage. So a percentage goes from 0 to 1. So if you are getting a prediction that's greater than 1 or negative, you know that you're doing something wrong. Let's scroll down to our train. So here we have our train set. It's got 29 columns. I've talked about the IDs. So the ID starts with 0, so we're looking at the 0th square in January of 2001. The fourth column is the burned area. So in January of 2001, we can see that there was 0% burned area in that square. You are welcome to try and plot this. If you want to try a bit of GIS or plotting, you can play around with that. ChatGPT is a great resource. Something that Colab introduced last month, I think, is Gemini. So when you create a new cell, you can ask Gemini, which is similar to ChatGPT, to write the piece of code for you. So you can maybe explore that. Next, we have the test file. I want you to notice that there's 28 columns in this file, which means it's missing the burned area column, because that's what we need to predict. On Zindi, on our backend, the file that only I can see has the burned area. And so when you submit your predictions, the Zindi platform compares your predictions to the actual reference file or gold standard on our backend. So next we're going to, once we've written all our files, we're going to do some feature engineering and some exploratory data analysis, EDA. So when looking at the train file, we can see that we've got about 83,000 values. Our burned area, if we look at the minimum, there's 0, which is understandable that there was no burnt area. And the maximum burnt area is 0.84. This is important to note. So when you get your predictions, I enjoy doing some post data analysis. So post data analysis would be something like, once you've gotten all your predictions, I would double check that none of my values are greater or significantly greater than 0.854. I'd also hope that the standard deviation is similar to what's in the train. If it's severely different, I would maybe question my model. If we scroll down to our next plot, some of you might be used to seeing a different correlation matrix or a heat map. This is just a different way of viewing a correlation plot. So we can see that land cover 5, climate SRAD, climate PET, those have a somewhat positive correlation with the burned area. In the middle, land cover 2, land cover 0, land cover 1 have a very minimal correlation with the burned area. So maybe when you get to modeling, you might want to drop these as they might not be too significant. Or you can do some different magic, some feature engineering to maybe pull out some stronger correlations. I have a question from Augustine. Burned area is the target. I'm sorry for not making that clear. Then on our left-hand side, we have climate vapor, climate precipitation is negatively correlated to burned area. And that makes a bit of intuitive sense. If it's wet, it probably isn't going to burn. If we scroll down a bit further, I'm just plotting here for about 10,000 points, and now we're looking at some of our clusters. Can you go down to the next plot, please? The one with the scatter plot rows. Rose, are you there?
Can you hear me?
I can hear you, and I was seeing your screen, but it froze for a bit. Great. Rose, while you're sharing your screen again, Lydia has a question. Um, how were the train and the test sets created? That's a great question. So this is, I mentioned the
Hello?
word forecasting before. So this is where forecasting could be used. But all data before 2014 is for the training period, and data after 2014 is for test. So so you need to predict for the years 2014, 2015, 2016 what percentage of Zimbabwe was burnt in different months. Great, Rose, I can see your screen. So over here we can see this is against climate vapor. Our maximum burn is about 0.65, 0.61. But if we remember from the table above, our maximum burn was about 84%. And the reason it's 6.1 here is because we're only plotting a sample of the data. I'm going to go a bit quite quickly over the next chart as well, as it's again just plotting against precipitation this time instead of climate vapor. You can scroll down to the next chart and the chart after that. So adding the date features. So I was quite mean in this data set. I used the ID, and you'll find this is quite common for Zindi competitions. For the ID, I said the area, so tile 0, tile 1, tile 2, underscore the date. So having these tile 0, tile 1 isn't the most important to the starter model that I'm building. However, it could be interesting later on. So what I'm doing in the adding date features is I'm removing this 0 and this 1, the preceding 0 and 1, and just allowing the date just to be by itself. By allowing the date to be just by itself, it allows you to do a bit of forecasting if you'd like, but it also allows us to see the most popular burn months or the most popular burn years. So if you scroll down to the next, so this is the mean burn area by month. We can see that month 9 is where we have most of our fires, and Perkins can maybe attest to September being the hottest month. If we can just see the burned area chart nicely, that would be great, Rose. And then in January, we can see that there's hardly any fires. This would be a post-processing or post-prediction check I would do. Once I get my predictions, if my January month had all the fires in it, I'd know that something was a bit wrong because my train tells me that fires are most common in September. If we go to the next chart, again, it's quite similar, except we're not plotting by month, we're plotting by year. And we can see that fires, there was a bit of a peak in 2008, but they're quite steady. Cool. Scroll down a bit more. Over here, we get to see just the monthly pot. I should have changed it around. The burned area is in blue and the precipitation is in orange, but I think those colors should be swapped. But over here, we can see quite nicely that if there's precipitation, so if there's rain, the burned area goes down. The importance of doing an EDA or exploring the data is just to understand what the data is doing. This is quite nice for this project because we know that fire is closely related to rain, and that's quite an intuitive fact. But as we start getting into fields that we don't know too well, or fields that are just confusing, such as forecasting network issues. This is where it's really useful to do plots and to find those trends. I've given you some ideas on more features that you can look into and to create. Bekan, I see that you've got a question. I'll answer it in a bit. So let's go to the data split and validation. So Lydia, this is going to comment on your question about the train and the test. So Zindi, normally from a client, we're given this big full data set. We take that big full data set and we pre-split it into for you. So we pre-split it into a train and into a test. For the test set, we keep that target, which is the burned area, on our back end. So in this competition, you've got your train set, which has got 29 columns, and your test set, which has got 28. I'm now talking about doing a data split and validation. What this means is we're going to take our train set given to us from Zindi, and we're going to sub-split it. It gets quite confusing because we sub-split it into, we take train and we split it into train and test again. Sometimes people call it train and validation. I used train and validation here just so I don't have to get confused with using test over and over again. So just like Zindi did, that everything after 2014 is for test, with my new with the train set that I've split, I've said everything after 2011 is test. And this is for me just to build my model. And I just want to train it and practice on the test set. And once I get a good answer on the test on the train set, I'll apply it to the test. It took me so long to get the jargon of train and test right. So Shadrach has asked a question, can I rely on train and test split instead of cross-validation? You can, however, I don't think it would be a strong modeling technique or validation technique. I think you do need to do your own cross-validation as what's shown over here. So in my simple model, I've chosen to use these columns as my input, so my input columns, and I've specified my target column as the burn area. In your input columns, you can decide to maybe remove some of those variables that had a low correlation. If you created any new variables or features, you can add them in here. The next line of code, I wonder if ChatGPT might be better at explaining it than me, but this is a good way to listen to me, watch some YouTube videos, and then see if ChatGPT can explain it in a way that you understand. So with our train set that we've split into everything before 2011 and everything after 2011, everything before 2011 is our train set, and everything after 2011 is our validation set. I really enjoy doing starter notebooks because I can make machine learning modeling look so simple. So my whole model is one whole line of code. It's the model equals ridge CV. So that is me just using an out-of-the-box, off-the-shelf model. I haven't done any parameter setting, any parameter tuning. So Bekan, this might be where cross-validation comes in handy because you'll be able to do more fine-tuning there. Or Shadrach, this is where it might become useful. So once I've trained my model, or once I've created my model, initialized it, ridge CV as model, I then fit it against my train and my prediction column of my train. I then apply it to my holdout set, to everything after 2011 in the test set. And now I have my predictions. What's What I find really frustrating is root mean squared error is quite a common metric to be used. However, sklearn does not have it as a metric. So over here, we're using the mean squared error, but you'll see that I do to the power of 0.5. So that's just my square root. So I take my actual values of the 2011 and I compare them to my predictions. And I get a score of 0.027. So that's my standard deviation. The computer still has this model in its memory and it's stored. And once I'm happy, you can come in here, you can train, you can change it. Once you're happy with your model, your computer will store it in its memory. And now we're going to go down to make a submission. In make a submission, we have our sample submission. So a sample submission is normally a 2-column file. On our Zindi backend, we have a 2-column file that looks exactly like this, except with all the zeros, we have the true values. So those true values are in the burned area column. Just looking at our test again, we notice that the burned area isn't there. So scrolling down, we do the same feature engineering we did to our train set. Thankfully, this was just changing the dates or to a date. If you did something fancier, if you did more items, more feature engineering, this might be useful to create a function so that you can apply it to both test and train instead of having to copy paste code. And then remember how I said that the computer remembers your model. Under the comment get predictions, we say model predicted on the test columns. And so our model just runs through and predicts that. We then save our predictions to the sample submission burned area. The sample submission, because it starts in January, we expect there to be no fires in January if we look at that chart that we created earlier. So I haven't done any of that post-analysis, but this might be a good place to do post-analysis. So once you have assigned your predictions to the sample submission, your final and probably most important step is to save your samples or save your file. Please note that I use an index equals false. Some of you might think that you have created this most amazing, beautiful solution and it just isn't being scored on Zindi. Open it up in Excel and double check that you don't have an index column. Alternatively, just ensure that you put index equals false. So, now that you've successfully run this notebook that Rose has delightfully shown us, you can then take that submission file, that CSV file, and you can put it onto Zindi. At Zindi, Rose, if you refresh, you should be able to make a submission. At Zindi, at Zindi, we don't run your code for you. We only look at your CSV files. So only if you're at the top 10 of the leaderboard do we ask for your code to be submitted. So because you've all enrolled in the competition already, there would be a submit button underneath the orange. If you just click on that submit button and drop the CSV file in there, it will work. Oh, brilliant. Rose managed to get it going. So there you just accept and join, and there's the submit button that you can just click. So you can either drag and drop your file in or just I see that a lot of questions have come through, so I'm going to start answering from the bottom up. Oh, So this is a sneaky way to test to see if you know how your submission is doing. You just download the sample submission and make a submission, because a sample submission should work. We're just going to give it a moment to start. Starting at the bottom with Sarah, do I have to be in a team to participate? You do not have to be in a team. You can participate as an individual. If you'd like to participate in a team, you can. Rose, do you want to show how to create a team? So you're going to click the team button. You're going to type in the name of your team, such as the best team. And then to invite a member, you'd click on the invite button. Most importantly, you have to put the user's username in there. So Sarah, say you want to be on my team. My username is Amy_Bray. So you would have to put that in exactly. But Sarah, if you don't want to participate in the team, you can go solo. How did we collect the data? That's a great question. You can cancel out of team. You don't have to add me to your team. I think it also might be because I'm already part of another team with someone else because I was trying something out, Rose. So, Rose, if you go to the data tab, you will see, I want to see the variables, so scroll up. Yeah, stop. So, Yusuf, if you look at, there's developers, Google Earth Engine, so climate, where all those extra URLs are. Those link to different satellites, I think, that Google Earth Engine collects. And there's some pretty extensive script libraries that you can go through and try and download the data. It's not for the faint of heart. The way we have obscured Zimbabwe is quite difficult. So even if you tried really hard and tried to go and find the actual data, I don't think that you'll be able to get the answer straight off Google Cloud. But Google Cloud is a great place to go and get land observation data. Shadrach, I've answered yours. Okay, Bekan, I'm new to this hackathon. Do I have to submit daily? Sean's answer, no. You don't have to submit daily. You can if you want. You can submit as many times or as few times as you need or as you want. Enoch, I have your email address and I'll look into it. Can one use ChatGPT to write code? That's such a great question. And yes, ChatGPT is brilliant. It allows you to overcome obstacles. I would strongly recommend not saying ChatGPT write a model to win this competition, because you will have no idea what it wrote and you won't even know if it's right or wrong. This competition is, in inverted commas, low stakes because we're not dealing with, say, health data or personal information data. So I don't know if I would trust a model or solution written by ChatGPT if I was dealing with someone's health information. But yes, ChatGPT is great to be able to use to ask questions to get insight. Yeah, Ethel agreed. Use it to understand. Maybe go through my starter notebook and say, why did she do this? Was she crazy? What was the meaning behind it? Is there a more efficient way to do this? Perkins, I'll message you after this and we can chat about it. Or maybe we can have a webinar afterwards and we can show you how you can use Google Earth Engine to get information on the land. Joe Augustine says he finds ChatGPT useful to expedite debugging of code. That's a great use case. How are the points split between team members? If you go onto the prizes, you can see how points are distributed, but they're distributed by the square root of the size of the team. I'm going to pause, and if anyone has any questions, you're welcome to raise your hand and unmute yourself.
Amy, do you want the participants to unmute themselves?
Yeah, so if you've got any questions, please raise your hand and ask out loud. Alternatively, you can put it in the chat. Abdallah, I see that you're unmuted. Do you have a question for me?
Yes, yes, I have a question. Hi, Amy. My question is, if you are part of a team, can you also participate in another competition as an individual? I also asked in a chat about the limited number. I mean, is there a limited number of members of the team, or can be 100 in one team or more? Thank you.
Abdallah, that's a great question. So for this competition, your maximum team size is 4. Usually it is 4 people, but just double check the rules. Secondly, if you create a team for this competition, then you only need to work in your team for this competition. So say, Abdallah, you and I decide to compete here, but then a new competition comes out next week and you want to compete there, but I need to go to school. You can go and compete in that competition individually. Or you can say, I actually really want to try teaming up with Emmanuel and go and team up with Emmanuel there. So you only stuck to a team for one competition and then you can choose a new team. Does anyone else want to unmute and ask? All right, Abdullah, I'm glad that answered your question. Ethel, if you submitted your solution faster than the deadline, can you go do the... Yes. So Ethel, if you've submitted to this competition and you're happy with your score, then I encourage you, go play around, go find another competition. Zindi comes in waves, so sometimes we have lots of NLP challenges, and sometimes users get really excited about NLP. But if NLP isn't what you like, then wait for the next time a CVE competition comes up. But there's always a competition and there's always something new to learn. We also have practice competitions. So say you really, really, really wanted to try do object identification, and we didn't have a live object identification competition available. You can go look at our practice competitions or even a past competition and go and try out object identification or forecasting or something interesting like that. Cheers, Augustine. Thank you for coming. I'm going to stop recording the session now, and I'm going to stay on a bit longer. So if anyone just wants to chat after the session, please do stay on, or if you've got any other questions.